Hi, I'm Alan Wrights.
I'm Tom Hughes.
I'm Diego Ramos.
And we're here to you today to explain about the four main gas laws.
Those four laws are Charles' Law, Boyle's Law, Guy Lussac's Law, and the Ideal Gas Law.
And we're going to show you all these laws, and we're going to show you one example in real life.
So please sit back, relax, and enjoy the presentation. Boyle's law states that for a given mass of gas at the constant temperature, the volume of the gas varies inversely with that pressure. Now that's the textbook definition for Boyle's law, but I'm going to break it down for you and make it a little more simple. In 1662, an English scientist named Robert Boyle experimented with the relationship between volume and pressure. So basically, simply put, what I just read to you means that the more volume there is, the less pressure there will be, and the smaller that volume is, the more pressure there will be. So let's say I have a 2-liter container with 2 atmosphere pressure inside. If I shrink that container in half, likewise the pressure is going to double to 4 atmosphere. Now that relationship is called an inverse relationship. Robert Boyle also came up with a formula to describe this relationship, and that's called Boyle's Law, which is what I'm explaining to you. And the law for that is P1 times V1 equals P2 times V2.
The volume of a fixed mass of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. Now this is the textbook definition of Charles' Law, which was developed by Jacques Charles in 1787. And he came up with the idea that if pressure is constant of a gas, which means you aren't adding any more in and it's in an enclosed area, that as you increase the temperature, the volume of the gas will also increase. And this happens because as you increase the temperature, the particles move faster and faster, and there are more collisions up against the wall of whatever the gas is inside. And the formula for Charles' Law is V1 over T1 equals V2 over T2.
So a French chemist named Joseph Gay Lussac in 1802 discovered the relationship between pressure and temperature. So the relationship of pressure and temperature is initial pressure over initial temperature. So it's P1 over T1 equals P2 over T2. So for my example, I'm going to use children and food. Right? So we have candy is heat and sleeping pills is freezing. So you have 2 rooms, the one with 24-year-olds inside. And in one room, you fed all the 4-year-olds a bunch of candy and sugar. So they're going to be running, hitting on the walls, colliding on the walls. But then in the room where you fed them sleeping pills, they're going to be just laying on the ground, sleeping, not doing anything. And then that symbolizes pressure, because when they're hitting, bouncing the walls, there's more pressure in the room. But when they're just laying down, they're not moving as much. They'll probably be moving a little bit, but they won't be colliding nearly as much as if the room was higher temperature.
Hi, it's Alan again, and I'm here to explain more about one of the gas laws that we found most intriguing, which is Charles' Law. Now, Charles' Law, if you guys don't remember, is the relationship between volume and temperature. So as the temperature goes up and the particles start accelerating and colliding more, the volume is going to increase. And on the opposite spectrum of that, as the temperature goes down, there's going to be less speed in the molecules, less collisions, and therefore the volume is going to decrease. Now, we thought of an example that kind of a real-life demonstration that explains this through the use of balloons. Now, we're going to put one of these balloons, both the same size, in the oven, and the other one in the freezer. And we're going to check back in a little bit and see exactly what happens to the air in this. Alright, so I'm going to put this one in the oven, and I'm going to put this one over here in the freezer. I'll check back with you guys in a little bit.
Hi, I'm Diego again, and I just wanted to check back with you. Here we have the balloon that was in the oven, and you can see how it expanded because the molecules are bouncing around a lot faster, and they're making more collisions against the walls, causing the balloon to expand. Now let's go to the freezer. Now here we have the balloon that was in the freezer. So this balloon shrunk because now the molecules are not moving nearly as fast as they were. So they're not hitting the walls of the inside of the balloon as fast, so they're not colliding and causing it to expand and causing it to retract. Now here's a side-by-side comparison of what heat and temperature can do.
Hi everybody, and thank you so much for watching our presentation. We hope you enjoyed it. I'm Alan.
I'm Tom.
Here you go.
And thanks for watching.
PTFN. That's all for now.